Hello there, fellow math enthusiasts. Mrs. Delzati here. Today we're taking a look at Unit 4, Notes Day 2. We're looking at the angle measures of our triangles. So the first thing I want to talk about when it comes to these angle measures is the Triangle Sum Theorem. And what we're going to see is that the sum of the angles in a triangle is always going to be equal to 180 degrees. Now, with this triangle sum theorem, we've got two corollaries. Corollaries are just smaller rules that kind of make our life a little bit easier if we want to go ahead and we want to use them. If we don't want to use them, we can always go ahead and base everything on the fact that the two angles or the three angles in a triangle will always add up to 180. But what these corollaries are, the first one talks about the acute angles in a right triangle. And we're going to see that the acute angles in a right triangle, they are complementary. Complementary meaning that they go ahead and they add up to 90 degrees. And here's why. Is if we have this right triangle, I'm going to call this angle here x and this one y. I could say x plus y plus 90 is equal to 180. If I were to go ahead and I were to subtract the 90 on both sides, I would see that x plus y is equal to 90. Here is one acute angle, here is the other acute angle. The two of them together will go ahead and make 90 degrees, which means that they are complementary to each other. The other corollary that we have talks about the measure of each angle in an equilateral triangle. Well, the equilateral triangle, not only is it equilateral, but it is also equiangular, meaning all three of these angles, they're equal to each other. And if we were to go ahead and set up the triangle sum theorem that x plus x plus x is equal to 180, and we were to solve that, that's 3x is equal to 180, and divide by 3, x would be equal to 60. No matter how big or how small an equilateral triangle is, the measure of each one of those angles is going to be equal to 60 degrees. So let's go ahead, let's get some practice using these three rules here. If I take a look at number 1, I have a plain old triangle here with the three angles. The three angles are going to add to 180 degrees. That is x plus 68 plus 36 is equal to 180. If I go ahead and I clean that up, that's going to be x plus 104 is equal to 180. Now I could subtract the 104 on both sides, and doing so I would get x to be equal to 76. So all we do is we add those three up, we set them equal to 180. Number 2 is a little bit more complicated. It just has a little bit more algebra that we have to deal with. It's still the same idea though, that we can take those three angles, 2x plus 3x plus 7 plus 123, and we could set it equal to 180. Now if we clean that up, that is 5x plus 130 is equal to 180. I'm going to subtract the 130. I have 5x is equal to 50. And if I divide by 5, I get x to be equal to 10. All right, so all three angles, they add up to 180 degrees. Now, looking at number 3, notice number 3, I've got a right triangle there, okay? Since I have that right angle, think about what we remember. With the two acute angles, if we were to add them together, x plus 24 would also have to equal 90 degrees. Now, if we subtract that 24, that is going to give me x is equal to 66. All right, keep in mind if you don't like the shortcut or you don't remember the shortcut, you could always still say x plus 24 plus 90 is equal to 180. All right, I like the shortcut though, and I'm going to use it again with number 4. My two acute angles in this right triangle are going to add up to 90. That is 3x plus 6x plus 9 is equal to 90. I'm going to clean that up. That's 9x plus 9 is equal to 90. I'm going to subtract the 9. That's 9x is equal to 81. And if I divide by 9, I've got x to be equal to 9. All right, so these first two dealt with the triangle sum. These second two dealt with the fact that the acute angles were equal to 90. These next ones, well, if I look at number 5, I don't see anything special going on with number 5 in terms of a right angle or in terms of equal angles. So I've got to revert back to my triangle sum theorem that all three of these angles will add up to 180. That's 7x plus 34 plus 4x plus 7 plus 8x minus 13 is equal to 180. I'm going to clean that up. 7x, 4x, and 8x, that's 19x. 34, 7, and then a negative 13, that's going to give me a plus 28, is equal to 180. I'll subtract the 28. That is 19x is equal to 152. And if I divide by 19, I've got x to be equal to 8. All right, now number 6, that's a special one. All right, I see that all three of those angles are equal. And when I have all three of those angles equal, I know that this is an equilateral triangle. The measure of each angle in an equilateral triangle is always going to be 60, which is why I can go ahead and I can say 8x plus 4 is equal to 60. We'll subtract the 4. That is 8x is equal to 56. And if we divide by 8, I've got x to be equal to 7. All right, let's go ahead. Let's flip it on over. And we're going to talk about something called the exterior angle theorem. Now, in order to understand the exterior angle, we've got to talk about interior angles and exterior angles. Interior angles are angles that are inside the triangle. So if I look at this triangle, angle 1, angle 2, and angle 3, those are interior angles. Exterior angles are angles that are formed by extending a side, and they are outside of the triangle. So in this case, angle 4, that is outside my triangle, that is an exterior angle. Now I'm going to go ahead, I'm going to highlight angle 4 for just a moment, because it's going to help us talk about remote interior angles. Remote means it's something that is far away, okay? It's not touching that exterior angle. Remote interior angles are two interior angles that do not touch the exterior angle. So if I'm looking at angle 4, angle 1 is not touching it. Neither is angle 2. Angle 1 and angle 2 are my remote interior angles. 3 is touching it. It's not remote. Now, the idea of the exterior angle and the remote interior angles, they have a relationship to each other. And what we're going to see is that the sum of the two remote interior angles is equal to the exterior angle, which means I would go ahead and I would add up angle 1 and angle 2, and I would set it equal to angle 4. All right, let's see how that works with number 7. I'm going to take the remote ones and I'm going to have them add up to that exterior angle. That 26 and 43 are going to add to x, meaning 69 is going to be equal to x. Let's look at number 8. The remote interior angles, when I add them up, they're going to equal the exterior angle. 33 and 90 are going to add up to 15x minus 12. Let's solve that. That's 123 is equal to 15x minus 12. We'll go ahead, we'll add the 12 on both sides, which gives me 135 is equal to 15x. And if we divide by 15, we get 9 to be equal to x. So the two far inside ones add up to that outside one. All right, let's go ahead. Let's take a look at number 9. Number 9 I really like. Okay, this one I like to call the bow tie. Why? Because it kind of looks like a bow tie. So let's go ahead. Let's look. I want to find 1, 2, 3, and 4. Now notice angle 1 belongs to this triangle on the left-hand side. To find the measure of angle 1, well, I could go ahead and I could say 180 minus 62 minus 84, which is going to go ahead and give me 34. That's what my measure of angle 1 is. Now, do you guys see how angle 1 and angle 3, those are vertical angles, aren't they? So if 1 is 34, doesn't 3 have to be 34 then as well? It does. We're done with that one. Let's look to go ahead and find angle 2 now. Angle 1 and angle 2, they make up a straight line. So to find angle 2, all I have to do is 180 minus 34, and I'll see that angle 2 is equal to 146. And then lastly, to go ahead and figure out angle 4, well, angle 4 is part of this triangle on the right-hand side here. I know that there's 180 degrees in that triangle, so I could say 180 minus 34 minus 45, and I'll get that the measure of angle 4 is equal to 101. How'd we do with that? That wasn't so bad, was it? All right, number 10, not so concerned about. I'm going to go ahead and cross that one off for us. But I do like number 9. I think it kind of draws together the idea of our triangle sum theorem. It brings back vertical angles, and it talks about our linear pair then as well. So, Dal's Audio is done for today. I will see you in class.